All right, hi everybody. So we're working through the chapter on rationals, and so we're going to fill in this chart here. This chart is really just about giving you three different rational functions here, and we're asking for the asymptotes and how it affects the domain and the range. Okay? Now, what you should know about this as we go through this is that the rule that we're about to establish here really is only going to apply on the diploma for this course, but beyond this, some of the stuff that we're going to say here is not necessarily true. So let's take a look first of all at the expression here, y equals 4 over x. Okay, so to start off with, I can see that this thing is going to be undefined when x is equal to 0, so the domain is quite clearly x can't equal 0. Now, because there's nothing here to cancel, there's no factors, numerator, denominator, I am stuck with that x in the denominator. That's what I might call an essential discontinuity. I cannot get rid of it. So my vertical asymptote is then x equals 0. For this one right here, again, if you compare the numerator to denominator, the degree of the numerator is less than the degree of the denominator. Now, what that means is the denominator is going to grow. As x gets large, the denominator grows really, really fast. And so the value of the fraction plummets to 0. So what happens here is we're going to get a horizontal asymptote at y equals 0. Okay? And that only happens if the degree of the denominator is larger than the degree of the numerator. If that's the other way around, then there is no horizontal asymptote. Now, in this context of this course, what that means here is my range will be y can't equal 0. Okay? So we're going to see a connection between domain and vertical asymptote, range and horizontal asymptote. So let's move on really quickly here and do the same thing. For this second function here, 2x minus 1 over x minus 7, again, it's undefined where x is equal to 7. Okay, that's where the denominator goes to 0. And there's not much I can do about that. I can't cancel anything, so I'm stuck with that, which means that my vertical asymptote is also x equals 7. If I compare the degrees of the numerator and denominator, they are the same, which means that this function ultimately, as the values of x get really, really large, this function is ultimately going to be modeled by 2x over x. Those are the dominant terms in the numerator and denominator, and if you cancel the x's, you're left with 2. So what we're going to get here is our horizontal asymptote will be y equals 2. Which by default means that our range is y cannot equal 2. And I hope you're kind of seeing how this works here. First of all, I figure out my domain, then I figure out my vertical asymptote, but the other way around, I'm going to figure out my horizontal asymptote first and then come up with my range. For this last one here, this last function is going to be undefined where x is equal to 2. This is 6 over x minus 2 minus 3. So this is going to be undefined where x is equal to 2, so that's my domain, x cannot equal 2. And that means, and again, I'm stuck with that, I can't cancel that factor out there, so that's going to become my vertical asymptote, x is equal to 2. When I compare the degree of the numerator to the denominator, now I'm going to zoom in on this one here. When you compare the degree of the numerator and denominator here, notice that the denominator's got a higher degree than the numerator, which would imply a horizontal asymptote of 0. Now that's true as long as you exclude that negative 3. But because there is a minus 3 here, think back to what that means. That's a vertical translation 3 units down. So what that means here is that my horizontal asymptote, instead of being 0, is going to be y equals negative 3. And then as a result, my range is going to be y cannot equal negative 3. And so here is the full chart here. We just want you to see the connection between those properties of the graph.